We've spoken before about different types of machine learning. Let's talk tonight about deep learning, and this is going to be a little bit on the developmental side rather than the user application side. And I think that's fair because we have a lot of engineers and programmers in our group, and besides that, there'll be some takeaways here for those who are not programmers or developers or engineers. Now, I think I have to motivate for you that this is relevant. In other words, a lot of people would say, well, deep learning is an academic thing. It's not really relevant to a practical training or trading. And I think that is not the case. If we look now at somebody like, as one example, Marcos Lopez de Prado, the author of Advances in Financial Machine Learning, you see that he's combining the academic and the practical trading. He's global head of quantitative research and development at Abu Dhabi Investment Authority, and you'll see that pattern reflected across the whole of machine learning. The academics and the traders have converged to a large extent, at least at the advanced level. So we need to monitor what they're doing, and I think we can learn a lot from it. Now, as to why this particular topic that I'm going to talk about is relevant, and to show that it is, here is a group that's been started by Hudson and Thames, which is a very well-known library author, a company that has published the ML libraries at ML FinLab on their website, which are very widely used set of libraries in Python. And they had started a reading group for some of the most significant papers in financial machine learning. And one of them is deep momentum networks for trading, as you can see here, my cursor. So if they can do it, we can too. I don't have access to their group. It costs quite a little bit to join, but we can discuss some of the same topics. We've already done meta labeling. Let's go now to the deep momentum side. Now, to further convince you that this has some relevance to reality, let me find here an announcement that was made in December 2021. Google announced a temporal fusion transformer, which is a type of neural network. And you can read about it at the link here. And they say that they found that comparing their TFT, which is Temporal Fusion Transformer, which refers to the idea of being temporal fusion, means they're not looking back just at the most recent data. They're looking way back. They're fusing time together. At least that's my interpretation of it. Perhaps you have another one. Let me ask, has anyone here used TFT? Where's the chat? Let me just see. I guess I can't see. Okay, I don't think there was any takers there. Oh, that's me, I see. So let's consider, and I'm going to make this a very hands-on how-to demo to get going with a use of that temporal fusion transformer of the TFT by the Man Oxford group, which is one of the most advanced groups of research in trading. But let's make sure of a little context first. We have machine learning versus deep learning. Machine learning, now, of course, really, let me see. deep learning is a subset of machine learning, which is a subset of artificial intelligence. But deep learning, just to make it really simple, is mostly adding neural networks into the mix. So for machine learning, we have what was called meta labeling, or trading strategy improvement, was originally in Marco Lopez de Prado's book. Ernest Chan has written about it in his book, and it has a service using it. And he says it's the most successful type of machine learning. It's basically uses decision trees, random forest, and gradient descent of various types. Now, deep learning, on the other hand, is a more general form of learning using neural networks. And there's been some difficulty in applying it to real trading and investing problems. Nonetheless, the Oxford Man Group and others, based on the Google library and other work they've done, say they have achieved success in using it. And we have to look at it, I think, to at least consider it for use. There's several types of deep learning, RNN, LSTM, and reinforcement learning. RNN being recurrent neural networks, meaning it loops on the input data over time. And LSTM is long short-term memory. Does anyone know how to parse that sentence? Does anyone know what LSTM is? Okay, well, there's a link here. We'll explain it. But it has to do with preserving its long short-term memory. In other words, it has a long memory for short-term memory. Anyway, these are theoretical details that we don't really need to deal with it as a pragmatic basis. As of today, there's major libraries. TensorFlow or PyTorch are the two most popular libraries for deep learning. Is anyone using TensorFlow or PyTorch? I think I see how this is supposed to work. I'm still trying to figure out where to see the chat. Anyway.
Oh, it's mainly TensorFlow.
You have looked at it?
Yeah, no, I use it at work.
Oh, use it at work.
In reinforcement learning.
Excellent.
And yeah, we use it at work.
And are you using TensorFlow or PyTorch or something else?
No, we use TensorFlow. Sorry.
Use TensorFlow.
I thought you could see the chat, but in the chat it's saying TensorFlow is the only answer.
Yeah, TensorFlow is sort of dominant right now. It has its control or popularity has swung back and forth over the years. TensorFlow is sponsored by Google, and PyTorch is sponsored by Meta or Facebook, as it used to be called. And some people, well, I won't get into that. Let's say these are just, what type of application are you using it for? If you can say, or you don't have to.
Oh, okay. It's federal contract work.
Federal contract work. I mean, can you say if it's in the financial area or not?
It's not.
Okay, it's not in the financial area. So really, but it's great that you're using it anyway, and that's quite interesting. Have you thought of using it in finance for yourself?
Yeah, I'm reading a few books right now. I'm a very beginner to the finance in general. I come from a computer science background, so I have quite a bit to learn.
Well, it's sort of ironic that we're having deep learning libraries controlled effectively by these two dominant and enterprises in the industry. But anyway, so let's get into this a little bit more. So, both can use CPUs or GPUs, graphics processing unit. Do you use graphics processing unit?
Yes, I do.
You do. See, most people are using it now. And the reason is that it has a greater parallel capability. If you look at a neural network, it has a lot of array processing, tensor processing, if you want, in it. And so, believe it or not, this will be a surprise to some people. Most of the computation is being done in your graphics card, if you have a powerful enough graphics card. And there's even a special type of card, a TPO. Now you can use all these on Amazon as well as or Google hosting. So you don't necessarily have to have them in your own personal PC, which is one interesting aspect of this. Anyway, again, we're using neural networks in these approaches, which have layers that propagate to each other using nonlinear transfer functions. Anyway, I won't go into that right now. So this is the Temporal Fusion Transformer that Google came up with, and it has layers. It has an attention capability, which refers to focusing our attention on particular events in the past, in the time sequence, and that kind of thing. Again, I won't get into those details. But if you look at the announcement by Google, they found it was better than everything else, TFT. And by the way, there are cases where it is not. But anyway, it's for a lot of cases it is. And just to show you that Google is the kind of work it's doing, it does include finance. Now, Man Oxford took it into their own tooling. They already had all of these different aspects of their work. And so they're looking back and comparing work with TFT, which is toward the end here, versus other strategies, including even a log-only strategy or a time-sharing momentum strategy, which would be buy on strength and sell on weakness type thing. And they got Sharpe ratios of 2 to 2.5, as you can see here, on the TFT. Now, the CPD means it's a variant of it, but it's not that much better, in my opinion, looking at these numbers, looking at the Sharpe, that you would have to have it, So mostly I just looked at TFT. They call it decoder only TFT. Anyway, that's just a mode of use of it. So I thought it would be interesting to download the code and see if I can get it working. And that's what I'm going to talk about. I did. Now, within limits. And the limits are that we don't have much resources. And you have to pay a great deal for, like they have, I think this is over like 50 or 100 commodities that they run their tests. And if you try and run it, I mean, it bombed out in every environment I tried it on. So I cut it back to one single commodity just for test purposes. Eventually, if you want to pay up, certainly the resources just there, the same code will work just fine on those platforms. Now, as I mentioned, it's a very nice trend, don't you think, today, that authors are publishing their source code on GitHub in its entirety, along with the papers. So you can go there, and that's what I'm going to mostly talk about today. What they've published, their work, download it, try and get it to work on our own machine. Because what better way to get some actual experience with momentum networks, with deep learning in general, than to actually deal with some real code. You can see the code they've used. And are you really going to get anything playing with trivial examples? The answer is no. So I think what you have to do if you want to really get into it is start playing with the code. And I mean, it's a great change that we have access to that code, because this is, again, from the Man Oxford group, and they're one of the leading users of TFT. So I don't think from Google you're going to get any realistic financial applications. You can start with it, but I don't think you can stay there. So they took a simple, as the basic use case or test case here, they're looking at time series momentum strategies. And this is called trend following, as you know, or follow the winner. And the basic theorem is that a stock with the highest return in a year tends to have higher returns the following year. Now, this contradicts the efficient market hypothesis, but nonetheless, it's true. Is anyone trading a straight momentum strategy? I mean, something like the options trading strategies that we normally trade are very, very different. They're trying to exploit a very broad edge, which is the risk premium, well-established risk premium in pricing of options. So that's mostly what we look, and it's a pretty rich premium that we can have for free, theoretically. All we have to do is catch it. For a trend following system, it's much, much harder to find an edge there. And nonetheless, there's a huge number of people who are trading trend following systems. And it's a much simpler case to start with than something like a broken wing butterfly. So which we might eventually want to test as well. But for this purpose, they're starting simple with a time series momentum strategy. Now, you might say, is this of any importance? And the answer is yes, because most commodity funds, which have a large percentage of investor money, use a follow a trend following algorithm on currencies, on stocks, on metals, on oil, and because that's just the way it's been for a long, long time. And there's huge, a huge number of people are hugely invested in trend following strategies. Now they have losing periods and they have winning periods. And it's a very difficult strategy. A lot of firms bomb out on it. And I imagine people know that, but there is an edge there, but it's pretty thin. And yet, these results have succeeded in improving that. And they've got a positive and a Sharpe ratio of one to, let me see, where's the Sharpe, of 2 is pretty decent. And the nice thing about a Sharpe ratio, as you know, is you're not just looking at return, which is meaningless. You're looking at return divided by risk. Sharpe ratio, any of the other ratios, they're all similar. They all get similar rankings. So these are honest results because we're looking at those ratios. They automatically say with a high Sharpe ratio that your losers are not dwarfing your winners, which is often the hidden case really in other strategies that claim to be winners. I mean, obviously it's the huge risk of any form of trading is huge losses. But that's why we look at the Sharpe ratio or the Sortino ratio or the Kalmar ratio. And also they have the maximum drawdown there, which is very, very low. There are actually two types of trend following strategies, momentum strategies, you can stay within a single underlying, single entity, a single market vehicle, and that you could call a univariate momentum strategy, or you could use a cross-sectional strategy, which would be by the top performing decile. I mean, we saw that being exploited in the strategy we had outlined in the first part of our meeting. He's looking at the decile or the quantile. He was using implied volatility, I believe, in that case. So obviously, look back windows are a key factor. Let me see how I've covered these first slides before I get into the substance of practice of doing this as an exercise. Okay, so for the first step, if you want to start getting this code to work on your machine, could be, and I'm going to suggest here you install Unix, which is a bit of a heresy for those who like Windows a lot, but it isn't as bad anymore as it was. Now, these days, you can run WSL2 very easily on just about any, I mean, you might want a few gig, I guess, any Windows 10 or 11 machine. And it becomes fully integrated within Windows. That's where you can download it from. Now, an alternative to all of this, setting it up on your own machine, is to use in the cloud, and I'll get to that in a minute, because you can do that too at no cost. Then I would suggest install Visual Studio Code, a nice Python editor and debugger. The nice thing is, if you use it with WSL2, and then it works. It just works. So you have your GUI running on the Windows side, but your data and your Python code executing on the Linux side. You might say, well, why wouldn't I run the Python code on the Windows side? And you can, but if you take existing distributions off the website, additional GitHubs, code off existing GitHubs, it's going to have been running in all probability on Linux. And so embedded within the code is going to be all sorts of directory manipulation, file manipulation commands, etc., that only work under Linux. So to save yourself a lot of hassle of changing that code, it'll pay off, but only if you're using existing. I did get some of this code to work under Windows' own version of Python. You have to install Python if you want to install it on your own machine. And the version of Python I would suggest is Miniconda. Would anyone agree or disagree with that?
I agree. Yeah, that's the, in my opinion, best way.
Yeah, the advantage being what?
Environment management.
Exactly. Exactly. The traditional way was using pip and the PyPy package collection, which is the traditional way that tends to be cited in papers from universities and such. But it doesn't have package management, it does, as you were saying. Whereas with Miniconda or Anaconda, but it's just Miniconda, then you get to set up a variety of environments, because the reality is it's a bit of a disaster in Python, the way they do packages. In R, all the packages are recompiled for every release. Everything always works perfectly, with some exceptions, for any given new release of R, because they compile everything as one central facility. It's not like that at all in Python. And so the minute you try and install anybody else's package, they'll give you a list of packages, package requirements to install, and we'll see that in a minute with this Man Oxford code. And because you'll be running a different version of Python, and because some packages will already be installed, you'll immediately have conflicts that take you days and longer to resolve. So with Miniconda, you can set up a bunch of different environments, which are different package configurations. And that's what you really have to do for viability. If you want to be able to run multiple different packages, multiple different experiments, I should say, different distributions on the same machine. And now there is an alternative to running on your own machine, and it's called Colab. Has anyone used Colab?
Yeah, it's a pretty common tool.
Use that too.
Yeah.
You're our experienced person here. So let me show you how easy it is to use Colab. I'll just try and get a window here. You see where it is. Oh, there's one. And let me just go to Colab here. All you have to do is go to colab.research. I have the link in the notes, which I'll send you to the site. And you're immediately in Colab. You might have to sign some agreements, terms of use agreements, or sign onto your Google account. It's a Google offering. And it's a Python test environment in the cloud that's quite nicely configured. So if we look here, you see they give you a bunch of different existing examples you can use. Needless to say, they have TensorFlow with GPU. They have their own GPUs on these machines. So you can use some of their GPUs, graphics processing units, which again, deep learning has, because of the amount of intense use of computing used by deep learning, they've resorted to using GPUs. They use them extensively, and those are available in this package. But my own one here is Momentum that I have set up here. Now what I did is I downloaded I had a wrong key. So you can put the Momentum code that you've downloaded, any code from any library, any website, you can put on your Google Drive and access it, because the interface you have is a notebook facility where instead of just typing lines into a command line and instead of a GUI, through GUI, you have a notebook interface where the idea is you put code in the different cells, and then as you come back and rerun your code over and over again, you can just execute the cells that have code you want. These are called Jupyter notebooks. This is a particular Jupyter notebook. So it's just a means of providing a sort of a recall in a way, or organizing your code in little snippets. Now, in this case, here's some code you have to do. See, and you just run it by pressing this. I'm not saying it's necessarily going to execute right away, but it's going to access your Google Drive in this case. It may require me to do some things here. It says, permit this notebook to access Google Drive files, connect to Google Drive. Okay. So as you can see, this actually ran. And see, and here it showed the files I have. And so that's working. It'll take, I put this code in the notes so you can have it. It's there. And then you can execute. Here you see some of the command lines that I have from the instructions. Now, let me show you the repo itself, on the other hand, for the momentum transformer that we're proposing to implement that I have run. And here it is, trading with momentum transformer, and they give you instructions here. But what you would do is you would download the code, and just put it in your path. That's all. That's all you have to do. And they have the instructions here down, and they tell you how to get free data. People are always looking for data, so I thought people would be interested to know. Here you can download 600 continuous contracts for 600 features from NASDAQ free. And I think it goes back a long way. It's just a free sign up. I did it. Has anyone used the NASDAQ free data? Okay, good. There's a supplement to the Yahoo data that people are most often using, which I think does. I'm not sure if that includes features data and continuous contracts. I don't think it does. And so this is quite a rich data source. Anyway, that is, let me go back to the presentation for a sec here. I'll try. No, it's okay. So, okay, that's the PDF version. I got a different version. So, so let me go back to here. F5, Michael said. Yeah. So this is where we were. We installed Python. I pointed out that you can develop entirely on Colab if you want. They have a Jupyter-like notebook. Now, Amazon has its own version alternative here, which is higher capacity according to many people. But I started with Colab because I think it's better known. So this is quite a major change. I mean, here they are offering Python development environments in the cloud for free at a small level. You'd have to pay for higher levels with more resources. And quite frankly, I have that's code I mentioned to link together your Google Drive. Because if you were to paste the code directly from the GitHub into the notebook, it wouldn't make any sense. It's too vast. So let me show you also, let me go to this one too. This is the Google site for TFT itself, which is the let me see what we call it here. Temporal Fusion Transformer for Interpretable Multi-Horizon Time Series Forecasting. This is the code that they released in December last year of 21. And they have examples, I believe, where they've run it in numerous different industries. So you can look at that if you want. You don't have to, because let me just find here. Because the Oxford Man example I'm focusing on uses it, it includes it. So let me go back. Where did that? There it is. PPT. Yeah. So we've taken those steps. So there's the, we've done these things. Now we're at the step here. What? Okay. And I downloaded this successfully. I got the data. Now, I had to make a few, well, let me just look at some of the code again. Well, I can look at it. Let me show you code. That's what I haven't done yet. So I'll start code. There it is, I guess. Here is Visual Studio Code. So if you want to edit on your own machine, this is a very nice environment to do that. Now, okay. File, open, recent. Now you can see here that you can open, even though it's running in the Ubuntu subsystem on your machine, you can open it in code. And let's look at, so here's where I have downloaded the code from Momentum Transformer, Oxford Man code. And see, there's a few changes I had to make. First of all, see, you can also look at it on the machine. Where is that? Oh, here we go. See, if you look at your file structure, it has Google Drive, which is one thing, which I'm sharing with my online sessions, with my cloud sessions, but also Ubuntu. So you just list it, and you can access these files, even though they're inside Linux, and you can access them. You go home, do Brady, and mom is Momentum is where I put it, and the data that's downloaded goes here from Quandio. So I download it. It's very simple to access. See all the stuff that's downloaded. What's an easy one? Let's look at I guess ES, right? Yeah, ES. So it's just the settlement data of this continuous contract on ES back from 1997. Free. And the same for all these other futures, right up to date. And so they did that just to make it more usable. They were originally using another different source, but the Oxford Man people wanted to provide a demo that would be good and that everyone could execute. So Now, so that's the different directories they have. That's the data directory. Here are the main files that you would run. Run classical strategy is the main file. I'm sorry, that's classical strategy. You wouldn't necessarily run that one. And but you can also run DMN experiment is the main one. And when you start it, they will give you a choice of which strategy to run. So you can run LSTM or TFT, which is what I did. I did both LSTM and TFT, and it puts the results in here under different experiments. So under LSTM, it does it for each 1 year period, an experiment, an optimization. And in this particular one, for instance, in 2016-27, I got 1.13 Sharpe ratio. And here I got a negative Sharpe ratio. And so on. So anyway, so that is some of what I did. Let me just check if I have any more slides here. So here I have notes on how you can run it after you've downloaded it.
Hey, Don, can you maybe talk about, sounds like all these strategies are running on some kind of momentum as you described, but can you talk
Yes.
about maybe differences, maybe what their inputs are, or how they make their decisions? Are these black boxes that we simply can't see
No.
into without a PhD? Or can you tell us more about how these things are making their decisions?
It's mainly, well, you can use the components, the inference engine themselves, more or less as a black box. In other words, you don't have to alter the code of TFT itself. They just use TFT as a library. However, what they do is they iterate over the look-back period mainly. The algorithms are all right in the code. Like they simply call. Let me see if I can find that. See, run would be under here. Well, ultimately, they just set the experiment to, these are different look-back periods, 21 days, 63 days. So the TFT, I mean, they specify the time steps, and change point is look-back windows, how much of a look-back window. But there's no hidden code. All of the code is, Google itself has published the code for the inference engine itself. It's largely a matter of just changing the learning parameters there's a lot of other learning parameters as well in the actual learning exercise, such as learning rate and decay rates of various kinds that are standard, more or less common to all backtests. So let me just see here, deep momentum network.
Are there any examples where it's easy to compare the decisions made between, say, something like a naive momentum strategy like dual momentum with how TFT would make the decision?
I mean, that's very interesting you would mention dual momentum by Gary Antonacci, whatever his name is, because that was actually the predecessor of all of these momentum strategies that these guys are doing. Or at least they treat it that way in their accounts. In other words, they say, this first there was dual momentum, and then there were various others, and now people use deep learning instead.
I guess like I'm just trying to understand, where is the decision made to do something different using one of these libraries versus
Go ahead, please.
So here for momentum-based strategies, the main parameter is the look-back period. And you can, the point of these machine learning techniques is to find an optimal look-back period without iterating through every possible look-back period in order to generate the most returns. So it uses some computational shortcuts instead of rerunning the backtest every time. And those computational shortcuts are known as the neural network.
Okay, I think that really helped. Is that search not able to be, I guess, if I didn't know anything about neural networks and you said, oh, I ran my back test exhaustively over all the possible inputs and I found a great result, I would tell you, oh, so you just curve fit your data, and that result is probably not going to be realistic going forward. So
they use an elaborate, no, absolutely. They use an elaborate in-sample, out-of-sample regime. They never, ever use in-sample data in the results. In other words, these engines they use various techniques such that there's only one final out-of-sample. All these results are out-of-sample only.
Yeah, so the same weaknesses in curve fitting by exhaustively look back, the same biases from just in general backtest overfitting are going to be in the machine learning models as well.
If you fall victim to them, especially, right?
Yes. But I mean, by like you said, by separating the test data and training data, you can mitigate some of these to see if you actually found an edge.
They have a whole bunch of procedures where they even mess up the input data in order that it not be too closely curve fitted. In other words, there are things like dropping out some of the data and regenerating the optimization. And in other words, making sure that it couldn't learn the data itself, curve fit too much. Are you saying that? Let me just see here. Were you saying a minute ago, though, that you don't think they are able to avoid the curve fitting?
That's an opinion. I don't have any proof or anything solid.
See, theoretically, why would not the in sample, out of sample? I mean, there's a whole bunch of pitfalls you can fall for, including range setting from a knowledge of where the market eventually ended up. In other words, you're saying, well, I know it ended up high, so you sort of bias the set of parameters you try. But there's a whole bunch but isn't DePrato and all machine learning all about avoiding that bias?
Yes, but I feel like the main reason we use machine learning models is because they work. We don't exactly know why they work. So there is an unknown and unquantifiable amount of bias that the only way to find out where it is to use it in real life and see where it fails.
Well, I mean, these people are making extravagant claims because they're producing Sharpe ratios, which are entirely based on out of sample data. And they're claiming that there were no flaws in their methodology. Now, we'll see. But I think it's a heck of a lot better than all the other backtesting that's conventionally done, which isn't truly out of sample, as DePrato often mentions in his book.
Yeah, I totally agree with you. Their neural networks are absolutely the best at separating signal from noise. But I mean, there's using garbage in, garbage out. So, okay, not garbage in, garbage out. Oh, what am I trying to say? Give me a second here.
Yeah, I mean, it remains. I mean, it remains to be seen, but I think that's the way people are doing it today. So we may as well look at it. And this is what, if we don't do it, I don't think we have any chance whatsoever.
No, I completely agree with you that this is the best way, but I mean,
I understand.
Back to the fact saying that it's like, I mean, it's the best we can do is what I'm trying to say.
I mean, you really have to wonder why, why would there be such, what inefficiencies is it discovering? Why are there any inefficiencies? So I think you have to be very, very careful. And I mean, all it is really doing is doing the optimization you spoke about, John. But there's just so much of it that you can't do it by bulk. That's all. In other words, all this is doing, it's optimizing directly on Sharpe ratio now, by the way. It's setting that as the loss function in the optimization and the training. So not optimizing on return and then seeing what the drawdown was later. It's optimizing right on. It's just optimization, but it's just the computation that is necessary to do the optimization. There's nothing more to it than that. But it's so prohibitive to run a vast amount of data that this is the only way you can do it.
Got it.
That's all. If they could do it the old way, they would. This is just running all those combinations. There's more to it than that, though, because these people are also into interpretability. In other words, another feature of this model that I didn't mention of TFT is it identifies the features that are most significant, feature importance ranking, because your features are things like, are just maybe calculated values of oscillators and that kind of thing. Or if you want to throw in fundamentals, you can. But I think in this case, they were just using very straightforward technical indicators. I think they were using MACD a lot. It's just put that in there and let it optimize on it. But they identify which features were most significant. So you can pull out the insignificant features, which is a major advantage because people have complained about the lack of interpretability of machine learning in general. I mean, it's a huge complaint. Among other things, clients just won't buy it unless they have an explanation. So it will classify the features that are most important, and you can drop the others out. And another major advantage of it is that it now has regime detection. It's built into it. This is the same idea as they call change point detection. This is a major effort in where you have a huge amount of data. If you look at the papers, you can see that they're classifying and successfully classifying things like the COVID crash. I mean, they don't know to call it COVID, but they know to classify the regime successfully, and they're successfully classifying those regimes. So they're coming around to the question of interpretability that you mentioned, and they're addressing it. So, I mean, I haven't accomplished very much. All I've done is looked at, I run part of their example, but where else are we going to start? I mean, it's certainly tempting. And the other problem is the resource use is huge. Like they ran 50 or 100. I mean, I couldn't even run more than 1 or 2 without running out of memory, even boosting it up to, 16 gigabyte and so forth. So they're running it on some huge configuration. Anyway, just a starting point. Anybody else, John, or anybody have any other comments? What do you think, John? Are you skeptical still?
I just literally did not know, the big results table,
Uh-huh.
how are they different? But I literally did not know that. So
Oh,
I
I see what
was
you mean.
wondering, if you were going to get to it, or if not, since
Well, let me go
feel
back
I
to
needed
that.
ask.
Let me go back to that big results table.
I can actually provide some insight into that question.
Please go ahead.
Basically a neural network consists of a series of blocks that run certain functions, math functions, and using different series of blocks usually provides different results. And basically, these are all of the types of architectures, the arrangements of blocks that they use to get the results that they did. So they're just comparing which map of blocks, if you will, produces the best results.
Yeah, they have
So
specialized layers as well.
So would the inputs to all of these be the same?
Yes. I'm assuming, or else these results are useless if the results aren't the same, if the input is not the same.
Actually, they get slightly different results. I think they run it like 6 times or something. And this is the average.
Yeah, that makes sense. But the inputs would have to be the same for this paper to be of any use at all.
I mean, the more different the results were on iterations, the less encouraging it would be. And I have seen some people comment on that fact that they got, somewhat varying results. So that's definitely an aspect of it. I mean, we have to decide, are we just going to pass up on this whole because it's complicated? I mean, I don't know the answer, but that's the question. I mean, it wouldn't be as bad to expensive to complicated if we're a little less complicated an input set. They've got like 50 or 100 commodity futures. I mean, you also have to look. I have to wonder about some of these very favorable statistics, Sharpe ratios, whether they are only valid if you have a large number of diversified number of commodities. What happens in just one commodity? I have to look more into that.
John, have you looked at writing the API that converts or I guess it's never mind. Sorry, I answered my own question.
Converting the API to, were you going to say to R?
I was gonna say the results from the model to an actual trading algorithm, but then I realized that it's a momentum strategy, so there aren't many. You can enter the trades manually after looking at the output of the model. You don't. It's not high frequency enough to where you need a computer and a whole nother pipeline to go from the output of the model to the input of your broker.
I mean, I will think more about the issues you're both raising, definitely. Does anyone else have any comments or questions? Oh, is there anything in the chat? Oh, I finally found the chat here. Yeah, okay. We will make the PowerPoint available, yes. Does anyone else have any comments or questions? Is anybody else doing any work with machine learning of any kind?
Hi, Danny. I'm Don. I do some work with machine learning, yes. So like forecasting, and I try to do a little bit trading. So
You say you were doing some?
I'm just testing it. So not really nothing practical yet.
Oh, so yeah, I work in computer vision and reinforcement learning, so I'm using neural networks on a daily basis.
Did you say reinforcement learning?
That's correct, yeah.
Oh, wow. See, reinforcement learning is yet another strategy that's basically like game playing, right?
Yes, that's correct. You use a neural network against itself to try and discover an optimal policy.
A policy, that's right. And there's inverse reinforcement learning too.
I've never heard of that, actually.
It's there. But okay, who was it that was the other person? Can you say a bit more about your?
I worked on different machine learning applications, and I do a little bit at my work. I do a little bit of forecasting, but for trading, I haven't got to the practical part so that I can have something automatically trade or. But you can do like you can maybe do like apply forecasting to a stock and see if so basically that's maybe a little bit interesting. I'm not sure if it's useful for trading, but you can basically do different forecast, which this one is also a type of forecasting algorithm, it appears. So you can do like some different types of forecast, and then that could be potentially utilized as for people. So
is that a financial forecast or?
Well, I mean, yeah, it's like a demand forecast, or you can predict the stock price, or it's basically, I mean, most of that. It's a relatively similar problem. I mean, there may be different problems in like if you demand, if let's say you do like a demand of like items, maybe some items are new or like different problems in different fields, but similar algorithms basically. So it's not very different basically.
And are you using, and I think you said, did you say you were using TensorFlow?
TensorFlow, yes, sure. Yeah, I did look at some of the like I did there was like one code called like a deep trade as well. So I looked at that like a year or two ago, and so yeah, I'm interested in the space, but yeah, I haven't got anything. Yeah, I'm not using it practically to trade stocks.
Had you heard of this TFT?
No, I don't think I heard it. So, but
okay, but you've done. There's lots of other work I know.
There's lots of work.
Yeah. So, what kind of model are you using in TensorFlow?
I used well, I used we can use the different models for forecasting. We had like I don't use a lot of neural networks. I did like some like driving cars, like some pretty basic stuff.
Oh, really?
yeah,
driving cars.
then-
That can be reinforcement learning again, right?
So I mean, yeah. But like for forecasting, you can use like neural networks. I just basically, it's more like a level of you can't get it and you use it. Like you won't necessarily train it. So or the system will just train it itself basically. So
Well, it's great. Any other comments or questions? John, is there anything else we need to cover or?
I think he left the, I think he dropped off.
Okay.
Yeah.
Okay. And that was Alexander. I know. Okay, here's Rahim. My friend follows muscular portfolio for stock investing. Papa Bear portfolio, sort of similar to dual momentum. As they went, I'll have to look more at the connection to dual momentum. Does anyone have any more comments on dual momentum or? So what is Papa Bear portfolio, Rahim? Higher up you go, there are more TFs in the portfolios. Oh, I see. That's very interesting. So in other words, you're saying that would bring in more minor stocks, I suppose, more diversification. Anyway, I guess unless there's any further comments, we'll leave it at that. Thank you very much.
Oh, hey, Don, I was curious about your background in all this stuff, finance and machine learning.
Say that again, sir.
I was curious about your background in
My own background.
Yes.
Well, I mean, I've been trading for a long time, and I've tried all sorts of different approaches. I myself do have a background in maths and physics, and computer science also. Originally, I mean, I've been doing Java programming for a long time, most recently, but I've also been starting to get into machine learning as well. What angle are you getting at there? What is your background?
I'm heavy CS, just looking to get into trading.
Oh, really?
Yeah.
So you're coming from the scientific or engineering side, and you're interested in the trading side.
Yeah, I'm trying to work over to the quant side. Trying to. I know the competition is very stiff, and I did not go to a target school, so
yeah,
I'm not estimating my chance of success to be very high.
Well, I think you can do it if you specialize enough, or if you get the demonstrable skills.
Yeah.
If you try to be hard at a junior level, then you need the top schools and so forth. But if you can directly offer services, then develop some knowledge and skills, I think you may do better. Do better.
Cool. Thank you.
And after all, you can always just develop your own trading strategy.
Working on actually.
Yeah.